Today we'll talk about solving complex fractions that include fractions as the numerator and fractions as the denominator. Please keep in mind that the fraction bar always means to divide, and so this problem will end with us dividing the answer, the product of this numerator to the product of this denominator. Notice that I have different symbols that represent multiplication, just so we could get used to knowing that the dot means to multiply and the standard X means to multiply. So let's get started. First, let's start with our numerator. When we multiply fractions, we don't do any changes. We don't find a common denominator. The only thing we do is look to see if we can cross cancel or cross reduce. And in this case, I noticed that 4 and 4 both have a factor of 4 in common, plus 4 over 4 equals 1 whole. 3 and 5 are both prime numbers. They don't have any factor in common besides 1. So let's set up to multiply. 1 times 3 is 3, and 5 times 1 is 5. That is the answer to my numerator. I like to keep my fraction bar highlighted, and I like to make it a little bit bigger so it doesn't get lost in the midst of the problem. So now looking at the denominator, I also have to find a product. If I look at 2 and 9, they don't have any factor in common besides 3, as well as 1 and 10. So let's just multiply. Numerator times numerator. 1 times 9 is 9. And denominator times denominator. And 2 times 10 is 20. Remember, when you look in the cross cancel, you cannot cross cancel denominator and denominator or numerator and numerator. It must also always be a numerator canceled or reduced with a denominator. So in this case, I still have a complex fraction because there's a fraction as a numerator and a fraction as a denominator. And as we said before, fraction bar means to divide. So let's go ahead and set this problem up like a division problem. 3/5 divided by, because of the fraction bar, 9/20. So I want to keep my first fraction as 3/5. I want to change this operational symbol from division to multiplication. And then I want to do the reciprocal of 9/20, which is flipping it to become 29. I can multiply straight across and then reduce at the end, which is the greatest common factor, by dividing by the greatest common factor. But I would prefer to go ahead and cross cancel now to make the numbers more manageable. So knowing that if I put 5 and 20 in the T-chart, I know that the factors of 5 is 1 times 5 only because it's a prime number. Factors of 20 in order is 1 times 20, 2 times 10, 4 times 5. So looking at these, they both have a 5 in common and a 1, but the greatest common factor is 5. That's what I'll divide the 5 by and the 20 by over here, okay, just for those that forgot. 20 divided by 5 is 4, and 5 divided by the greatest common factor of 5 is 1. If I did the same thing in a T-chart with 3 and 9, I'll find out that the greatest common factor is 3. So let's divide. 3 divided by 3 is 1, and 9 divided by 3 is 3. So now I'm set up to multiply my new numerator times numerator, which 1 times 4 is 4. And then my new denominator times my denominator. 1 times 3 is 3. 4/3 is a fraction greater than 1 whole. So I need to go ahead and convert that to a mixed number by doing division. 3 goes into 4, 1 whole time, which equals 1 group of 3. There's 1 left over. Please remember this is your leftover or remainder. Remainder always goes the numerator on top, divided by the divisor. So the final answer is 1 and 1/3.